Alright, so this is the formula I'm going to use. So what I'm trying to do right now is I'm trying to rewrite this expression as a u and a dv. So I'm picking two separate things. I'm going to try to pick a u, so I'll put the u stuff over here, and I should be able to find du for. And then I'm going to try to pick a dv, because I would need to write it as u dv. So I have to pick u. I'm going to start with dv. I'm going to pick dv so that it is something that I for sure know how to integrate. I for sure know how to get backwards. And also, when you're picking u, you're picking something where the derivative of u is simpler than the u. Which one would you pick for which, do you think? dv is cosine of x. U would be x. Okay? So then, what's du? Just dx, right? Or 1. And then remember, this is dv, so this I'm trying to integrate. I'm trying to go backwards. What's v then? Sine of x. Okay. You want to pick dv. It should be the more complex expression, and you should be able to integrate it. You want to pick u, so we have an x and a cosine x here, right? So basically you have to pick which one goes with which. What you want to pick for u, when you take the derivative of it, it should be simpler, okay? So we picked x because when I take the derivative of x, it's 1. That's simpler than x. Alright, so here's what I do then, okay? So this is, I'm rewriting, I'm going to write it right below here. So x is like my u, and cosine of x is like my dv. And so what I need to do then to evaluate this, because is according to the formula we found earlier, we need to do u times v minus the integral of v times du.
Where does the dx go from the original? Where does the dx go with the du?
It's going to go over here. Okay. You ready? So what's u? And v is sine of x minus the integral of v du, which is sine of x, and what's du equal to? Dx. Okay. So I don't have to simplify this. I do have to integrate again on this. So what is the integral of sine? Negative cosine. I know, they're hard to go back and forth. Okay, so minus a negative means that this would be, yep. So this is going to simplify to x times sine of x, that's this part, plus cosine of x plus c. Okay, so let's try another one. Okay, so but now remember, if you're thinking x squared, here's the deal. Normally I would say, yeah, you're right, x squared. But if I put natural log of x here, we do not know how to integrate that, do we? No. So what's my only choice then? Let's make this here, and we're going to be dv is x squared, because we still can integrate x squared. Okay. All right. So what's du? 1 over x dx. I'm just going to make sure I write it in there, because there's going to be, technically, when you're doing an integral, you need to have a dx in there to integrate. And then let's go backwards. If dv is x squared, this would just be x cubed divided by 3, right? Okay. No. So, let's see now. This is my U. This is my dv. Okay. And so, once again, the formula is going to be U times V minus the integral of V du. Here we go. I can. All right. So, what am I going to write first? Okay. Now, do you notice that I can simplify this expression? X cubed divided by x is x squared, correct? Okay. I'm going to just keep simplifying here, so this doesn't change. Times x cubed over 3 minus the integral of x squared over 3 dx. Okay. So this was x cubed over, I'll just rewrite it as x cubed over 3 first, times ln x. This is x cubed over 9, isn't it? When I integrate it?
Oh, yeah.
When I integrate x squared over 3, isn't that going to be x cubed over 9? I know, but just check it with doing the derivative. Okay. And if you wanted to, you could pull out a common factor of 1/3 x cubed over 3, but you can just leave it like this. Okay.
So what is those? So what did we just find?
We found the integral of this expression because what we recognize is because it's a way to reverse product rule. Because I have basically two different things multiplied together, and it's not like when we did U substitution where one of the things is the derivative of the other. They're totally two separate functions. So it's this formula that I showed you in the book. Hopefully that made sense. I'll go back to the book again. Was derived from the product rule. And so basically it's a way that we can undo the product rule. Alright, let's at least get through example 3. And then I think I'll save 5 and 6 for tomorrow.
What did you skip?
What?
You skipped from 1 through to 4.
I did?
Yeah, just up 3.
What happened to 3?
Decided it's going to be a problem.
I don't know. I don't know what happened to it. Alright, what do you think? What's your guess? Here, I'm going to rewrite the formula up on top a second. So we need to pick a U and a dv, and then that equals U times V minus the integral of V du. That way we don't have to keep flipping. Yep, we're going to let U equal X because, and then we have, here's dv. That would mean dv is e to the x, right? Alright, so with U we are going to take the derivative. we need du, and that would just be dx, correct? And then for dv, we're going to integrate because we need v. So what would that be? E to the x. Okay, so this is my u, and this is my dv. And we're going to do, that's going to equal u times v minus the integral v du. So we're going to write x times e to the x minus the integral of e to the x dx. Alright, so what is the integral of e to the x dx? E to the x. So we leave x times e to the x the same, minus e to the x plus c.